Here's the question, and it's a very long question, and I've summarized it so you can pause the video, have a go at the question, and then here's the summary of it. Let's have a look at the solution then. The temperature of a fridge is minus 20 degrees C. d theta dt is equal to this differential equation. T is in minutes, K is a positive constant, so you can see the rate of change is minus this positive value here. Theta, find theta, initially theta is 40, so you can see that this d theta dt will be negative initially, because K is positive, so this whole value is negative, isn't it? So theta is the rate of increase, theta is the temperature, and d theta dt is then the rate of increase of temperature with respect to time. So let's have a look at it then. Find theta. So part 1, separating the variables and integrating then. So move the theta plus 20 underneath on the other side to be with the d theta, which is here. Leave the k as is, and then move the dt up to be with it. Separate the variables and integrating then. That will be a logarithm, won't it? So we've got ln of the theta plus 20, that's the integral there, is equal to minus kt, plus a constant of integration lowercase c. Unwrap the log, theta plus 20 then will equal e to the base moves up and hits all of this in the air, which is equal to e to the c, put that first, times e to the minus kt. Okay, so that tells us then what theta is. Move the 20 over. This e to the c I'm going to write as capital C because it's just an arbitrary constant. Minus kt minus the 20, isn't it? So there's theta. And we've chosen to write capital C instead of integral of e to the power lowercase c as our arbitrary constant. Now that's theta then. Initially theta is 40 and the rate of cooling is 3 degrees C per minute. So initially theta is equal to 40, t equals 0, and d theta dt is equal to rate of cooling is 3, so that's the rate of increase, so the rate of cooling will be minus 3 there. So let's have a look then. So put in this initial condition into the equation originally, which is, put this one in first. d theta dt is minus 3 equals minus k. So minus 3 equals minus k, theta plus 20, isn't it? So the minuses cancel, the 60 can go underneath, and we get k equals 3 over 60, which is 1 over 20. Notice that k is positive here, we're told it's positive, so that would avoid the error of putting minus 3 here, of putting 3 there, if you made that mistake. Because theta is the rate of increase, and that's why this part here is negative. So when it says the rate of cooling, you have to put d theta dt as minus 3. But you'll pick that up because k is positive if you put 3 by mistake, which is an easy thing to do. So that's the first thing, then k. Now another initial condition, we can put it in here. Theta is 40. C, e, initially t is 0, so that's e to the 0. So that's just 1. E to the 0 is 1. Minus 20, so that tells us what capital C is. Move the minus 20 over to plus 20. 40 plus 20 is 60. So, find the time taken to freeze to the nearest minute. So theta is equal to c, which is 60, e to the minus k, which is 1 over 20, times t minus 20. Find out when theta equals 0 then. 60 e to the minus 1/20th t is equal to 20. And that then tells us that e to the minus 1/20th t is equal to, move the 60 down, 20 over 60 is a third. Take logarithms, so minus 1/20 T. Move this down to write it in the log form. Is log of 1/3. And then that tells us what T is. Take the minus over here, and this will be log 3, won't it? So I'm going to do that. Log 3, and move the 20 up, and we get 20 log 3. So all we did was move the minus over here. Minus 1 lot of this is 1/3 of the minus 1, so that inverts the fraction. And once we've done that log 3 and got rid of the minus, we can move the 20 up to be times. And now let's do 20 times log 3. Close bracket. Equals 21.97, which equals 22 mins to nearest minute. Okay, that's the answer there, 22 minutes. So that's part 2. Find K, which we didn't, and the time taken to freeze to the nearest minute. Another liquid is initially at 90 and is 0 degrees after 19 minutes. What can you say about the value of K? Another liquid is 90 degrees. So theta equals 90, T equals 0. And then it says here, another liquid is 90 degrees and is 0 degrees after 19 minutes. And is 0 degrees. And theta equals 0 degrees when T equals 19 mins. Okay, so the rate of cooling here for this liquid is quicker, wasn't it? Because the other one went from 40 to 0 in 22 minutes. This goes from 19 to 0 in less time. So K will be a bigger value, won't it? The rate of cooling is quicker, greater. Here, the rate of cooling is greater or quicker. So K must be larger.